So the next task for us is creating the custom velocities to add the vortex or the tornado for our tap simulations. So here we can choose two different ways, but maybe there's a little bit more than two, but the two main ways is what is the source we're going to use for simulations. So we can create like a density field here in the bottom of our line, create like a smoke, and then using the velocities, just add velocities which will make a movement for the smoke along the curve. Or we can use the particles as a source for our smoke. So the first thing, we're going to create the particles here in the bottom area and create the forces for those particles. Create a tornado from those particles, and then using particles, create a source for our smoke simulation for the pyro. So let's create the second one method, because why I prefer the second one, because we have a little bit more options. And options, we can create a shape for our vortex using particles. And this is a very powerful tool, because when you apply just a simple velocities, it's not always visually representative how we can apply forces along this curve. If I want to have a bigger, the bigger radius in the upper areas or small radius here underneath this, sometimes it's hard to visually create a proper ramp or the proper shape in the pyro simulation. So we can create a proper shape using particles, which is more visually representative, and then convert those particles into the volumetric and using the pyro. So let's go here and create some base of our vortex. So let's add a tube. We can leave this curve with the template. So create a tube and make a radius a little bit bigger, like 10 by 10. Go to polygon and caps. Maybe add a little bit more columns. And then I want to select polys. So select all of those with the control, deselect the bottom one and remove those stuff. So I will keep just the bottom area, and this bottom area is, we have the height like 1. So now I want to transform this object like 0.5 up to have this circle on a 0 position. All right, so I'm going to use this for the particle generator. Go to the scatter, press the shift button, and here we can create some points on the surface. Cool. I just unselect this. So this is our burst points. Let's create a little bit more, like 50,000, something like that. I want to have a very dense areas. And now I want to add the pop network. So pop network will create the particles from those original particles. Okay, so go here, can remove that. Shift S, I like, in adopt networks, I prefer to use those lines here. So we can simply, using the Shift S hotkey, change those lines. All right, so how many points I want to create, and I'm going, except of the scatter out surface, I use the points. And now can check guides, go to the burst and choose the number of particles I want to create per second. So I'm going to use the constant burst rate. Let's increase them to like 25,000 per second. Cool. So I use the first contact geometry. As you can see, I connect this to the first input. And now what I want to do, I need to add some velocities. Now those particles doesn't have a velocity, they can't move anywhere because we have the inherit velocity option here, but we don't have a velocity, initial velocity in our particles. There's no velocity, so we need to add them. We can go here outside and add some velocity using the attribute WAP or something like that, create a curl noise, get some vectors, upper vectors, but we definitely need to use my curve to set up where those particles should move. Okay, so we need to create some force here on the pop network to make those particles moving along the curve. But in fact, we need to create not one force, we need to create 3 different forces. I work in many 3D softwares, and basically for an FX, I'm using Houdini, 3ds Max, and RealFlow. In all of those softwares, we have some options for creating a tornado, some built-in tools. In 3D Max, they're pretty simple because we can create a vortex around just the straight line. Okay, so if you want to create the custom forces, we need to using the like sinker particles. But in all those tools, we have 3 different forces to create a vortex. Let's say this is our curve. Here in the bottom area, we have some particles. So the first force which we want to add is the up force, which will push those particles along the curve. Okay, so the first is our up force. And it's not like a linear just up vector like 0, 1, 0, okay? It should be the vector depending of the points on the curve. So in each time of a simulation, when our particles are gonna move along this curve, they should find the closest points on the curve and see the normal vector from this point, and then transfer this normal vector to the force. When it came here again, in each frame, we would find the closest points on the curve, look on her vector, normal vector, and then set this vector as a force for moving up. So that's how we can apply the up force. Oh, let's leave F because with the mouse it's not very good thing for the typing something. So the first one is up force. The next one is our orbit force, which will make those particles moving around the curve. So basically it's going to create a vortex. And yeah, I draw this vector like a curve, but in fact we all know that we can create a curve vector. So if you look on this situation from the top, so again we have some particles here on the bottom. So let's say it's a top view, and we should create the vectors like here for our particles. So that's the orbit vector, and that will make this particle go around the middle, around on our curve. So that's the second one, which is orbit force. Orbit. Come on. And the third one is force, which we call attraction force. The thing is, the bigger orbit force, the bigger radius we're gonna have for those particles. As you know from real world, if we have some object and make a rotation for those objects, the force will push the objects from the center. So basically our orbit force will cause, you can see those particles try to go outside of this position. It's not just rotating, but going outside. So we need to add some force which will push those particles backward to our center of rotation. So the third one is the attraction force. The attraction. And we can simply create this force again in each frame or on each sub-step. We can take any particle, find closest one on this curve, and draw the vector from this particle to the closest points on the curve. And that will be our attraction vector. Each particle will have this attraction vector with the closest point on the curve. So, and you can see that those three different forces, combination of those forces will create the vortex. And in all 3D programs I work with, we have the same setup, 3 forces. All right. So basically, even here, we can find a node, which is calling the pop curve force. And you can see that we can choose the line, which is already have here. Let's connect it just to better see what is going on here. Select my curve, accept. And you can see that now we have some force which will push my particles. Let's play this. Which will push my particles from the bottom area, they slowly begin to rise because our force is pretty small. But we can have not just movement along the curve, but we have some rotation. And here we can see that we have all those 3 main forces. The follow scale is the scale for the up force. The suction scale is the scale for our attraction force. Well, we can call the suction, attraction, doesn't matter how you call it. They have the same, work. And the orbit scale again is our orbit force. So those 3 guys we will recreate using just a simple, or not very simple, but pretty useful WUP node. So yeah, we definitely can use this tool for creating a particle vortex simulation. And this tool is pretty powerful. In fact, we have the shaping, so we can control the the shape of our vortex. Let's say I want to make it a little bit bigger here, and even bigger influence radius, like 5. So now it will grab more particles from the bottom area, and then it will increase here, and it will use our curve as the source. So you can see that our force is moving with those our curve and animation curve. So let's say I will increase the strengths for those guys. Let's say maybe like 10, 10, 10. So it's a little bit more strength here. And you can see that we create some rotation. Just can disable my guide geometry. And now we have some particles moving along our curve. As basically it's not bad. So we can simply, very simply, create some kind of this effect. And you really can go to our global forces and say, okay, maybe my long length of fellow curve, we can change this here. Or we can go in here and say, okay, maybe my orbit force will be bigger, like here. Maybe suction force will be bigger here, or like this. Can choose something like Bezier. And we will have a little bit different shape. So the follow, I guess I will increase it like 0.5. So you can see it's pretty easy. It's very easy. We already have those forces. We don't need to create them. So we just use as we want. But what I don't like, in fact, in this situation, that even if we have some shaping option here, they will not create correct the same shape as I want. So if we back our guide geometry, where is you? Here you go, our guide geometry. So the shape is much bigger. They have a bigger radius, but we don't have such influence for the radius of my vertex. So yeah, we definitely can play with this tool, with this force, but I prefer to use my manually created velocities because they a little bit, you know, better as for me for creating the proper particle movement. So we can leave this like an option. If you want to play with this, you can definitely use the pop curve force. But what I want to do, I want to create a pop-up network. And I want to take my curve, this curve points, and find my forces. And the first force is our up force. So as I said, using the up force, we can find the closest point and look on the normal of this closest point. But if we take our points, go to resample, back here, press normals, we don't have any of those. If you go to geometry spreadsheet, there's no normals. We can remove the group because we don't need them anymore. So group delete. It's not a big group, so anyway, I just want to, you know, remove this, just all groups what I had. Because even if we have just a simple float attribute, it will create some parameters or attributes which we don't need anymore. So it's always good to clean up and have some less unuseful stuff here in simulation. So we don't have a normals. There is no normals here on the DOP sheet, and if we turn on them, we can see there's no normals. And yeah, if we go and say like we can add some normals for the points we have here after the sample, and we can use many different like normal, some different nodes, but in this case I want to create a tangent. And what is tangent? If I use a polyframe node, it has the tangent option. So using this polyframe, you can see that it's at two different attributes. It's a normal and tangent. If you look here, we can see that we have a normal, which is perpendicular to our curve. So it creates something like an attraction force, but in our case, I want to add in normals, which will go along this curve. All right. So how we can fix it? And we can see a tangent. Well, we can add it like some new markers. But if we turn off the normal name and said that I have a normal here and a tangent, it's a little bit difficult to see, but now we have a normal which is along the curve. All right, so if we go to our display options and where's my guides, and we have the scale normal like 20, I don't know, big scale, you can see that now we have normals along the curve. Let's make it just by default, 0.2. All right, and let's rename it. So we can use the normal by default, so we can use this attribute, but I prefer to change this attribute to something different, something custom, because sometimes if you want to get a real normals for some other purposes, I don't know where, but you need to find those. So yeah, again, points, that's the first thing I need to choose here, and let's go and set it to up vector. So now I have up to vector. I just set the normals the first time because I want to show you that this vector is over there. And another problem, this vector is going actually down. All right, so as I showed you with a bigger scale, we can see that our lines is going down, but our up vector should look up. Very interesting. So what we can use, we can go and set the attribute wrangle. So again, let's go visually. I want to show you, go to normals. And again, maybe add them like 20. Just to better understand, you can see that all these go down. So with the attribute wrangle, we can say that now my normals I want to set as minus normal. And then they will go up. The same normals, but now they're going up. Cool. And again, I don't need any normals. Just go and use the up vector. So I'm gonna choose this here and here. Control Enter. Now we have the minus up vector. And another option, we can use a reverse node, which is here, and we can make a reverse before the polyframe. Okay, there's, and this should be the same, all right? But you can select what method you want to apply. Anyway, using the attribute wrangle, using the reverse node, and you will have the same result. All right. So what next thing I want to add? Let's use this tangent, it's my up vector, to make those particles flying along the curve.